Okay, so in this video, dahil dun sa wala tayong sample problem sa reference kong unang lecture, I was able to find a problem from the book by Kwon and Bang, the finite element method using MATLAB. So na-verify ko na rin to sa MATLAB, of course. The goal is to solve this problem using SMATH. Okay? And of course, STAAD. Para naman, as an engineer, you will know that your theory is correct because you can implement a problem, a finite element problem, and solve it using a commercial software. Okay. So that gives you a fulfillment, no? Or a satisfaction that you are able to apply the concept of finite element in an actual practice. Okay, so ito yung model natin ng plate element according to sa problem. Okay, so 4 elements siya. Okay, so basahin ko muna yung problem. So a static finite element analysis of plate bending is performed using the shear deformable plate bending formulation. Okay, so ang theory na ginamit niya dito is the shear deformable plate element. So this is not consistent do sa diniscuss ko sa isang video, because what I discussed was Kirchhoff plate theory, no? Doon hindi ko consider yung shear deformation. Dito consider yung shear deformation. But yung Kirchhoff plate theory naman no? In actual pwede na, no? May konti lang naman yung discrepancy. And in most problem, definitely even in STAAD, when you do plate elements, when you model your slab using plates, ang default is I think walang shear deformation talaga. Okay? Na i-consider mo lang naman yung shear deformation pag yung thickness mo relative doon sa length is medyo naglalapit na, no? And in most cases sa actual yung slabs natin, ang nipis niya compared dun sa overall length. So therefore, yung classical plate theory is in general applicable naman talaga. Okay? So the problem is a simply supported square plate is subjected to a concentrated load at the center. Find the deflection of the plate using the shear, deformable placement formulation. Okay? So ang itsura niya is ito. Alright. Why this? Because you have to understand the problem first, no? Dinunawin ko na siya dito. Ito yung actual problem. Okay? So, supported siya all throughout, no? So, perimeter niya. Then, meron daw siyang concentrated load sa center. Vertical concentrated load. Okay? Now, in most finite element books, ang ginagawa is, as much as possible, get the symmetry. Okay? Then, dun mo hahatiin yung problem. Yung structure. So, since symmetrical to, okay, kunin lang natin tong portion na to. Okay, then, i-mesh mo yan. Saka mo siya i-mesh. Okay, so pag blino up ko to, tong quarter portion na to ng plate, eto na siya. Right? So, ang meron lang fixed support, itong dalawang gilid. Okay, and then, ito yung meshing niya. Right? Ito yung meshing. Okay? Then, therefore, itong concentrated load na to is nandito na. Yan. Okay? Yan. Okay? So, free itong mga to, no? Okay? Free itong mga to. Look, on this condition, no? Okay, now, kung kukuha natin yung section nito, yung elevation yan, ito siya. Alright? So, ang maximum displacement noon, therefore, definitely, Sa center. Kung nasaan yung location ng ating load. Alright? Now, kunin ko yung isometric nito. Ang isometric niyan is dito. Okay? Yan yung isometric view. Okay? So, meron kang vertical displacement W as discussed sa ating formulation kanina. And then, meron kang rotation on both ends. Right? With the theta x and the theta y. Now, for this problem, ang sabi niya, dahil hinati natin into quarter plates sa apat, ni-restrain niya, so walang rotation dito sa ating, sa gitna. Wala daw itong rotation. Yan. Instead, ang may rotation itong location na yan. Yan. Meron tayong theta x and theta y sa gitna na yan. Ito. Yan, dyan. Okay? Kaya, dun sa pagdating ko sa aking STAAD model, naka-restrain to. Where's the supports? Yan, okay? Naka-restrain. Para masabi ko na walang rotation dito. Okay? Instead, ang kailangan ko lang is the vertical displacement. Ang may rotation lang is ito. Kaya, how many degrees of freedom ang pinag-uusapan dito? Or how many displacement? How many unknowns? With that, ang unknowns ko ay tatlo dito. The vertical displacement, theta x, theta y, 3. Dito, may vertical displacement. Pero ang rotation lang, on this side lang. No? Dito, may vertical displacement. Ang rotation lang, itong side. So, 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore, ang total displacement ito is 8. Okay. Now, gumawa ako ng version na problem. Further simplify ko pa siya into 6 degrees of freedom. Inalis ko na lang yung rotation ng mga to. Kinuha ko na lang yung vertical displacement. No? So, 1, 2, 3, 4, 5, 6. So, yung SMATH code ko dito is only good for 6 degrees of freedom. Okay, let's see ano yung discrepancy. Alright? Okay, so continue. Yeah. So, the size of the plate daw is 10 by 10 and its thickness is 0.1 inch. So, in English units pa yung problem, no? Okay. It is made of steel whose elastic modulus is 30 times 10 raised to 6 psi and Poisson ratio 0.3. The applied force is 40 pound at the center. So, dahil quarter plate yung kinuha natin, madi-divide into 4. Maghahatian to mga to, no? So, 40 pound divided by 4, that is 10 pound. So, 10 pound is equivalent to how many kilonewton? Kinonvert ko na siya, that is 44 kilonewton. Okay, that's why sa model ko, ang loading ko ay, that's it, 44 newton rather. 44 newton. Okay. What else? So, I have 4 plates. And, now, this is the importance ng symmetry, no? Para ang ginawa ko, kinuha ko lang yung stiffness matrix ng isa. Kasi, pare-parehas naman sila. Diba? Pare-parehas naman sila, no? So, pag kinuha mo yung stiffness matrix ito, ganun din yung stiffness matrix ito. Okay? Magkakatalo-talo lang yung mga yan sa boundary condition. Right? Iba yung boundary condition nito, iba boundary condition nito, iba boundary condition, iba boundary condition. Right? Kasi, for example, ito. For example, draw ko siya. Itong node na to, fix yan. No? Pero itong node na to, for plate 1, may 3 degrees of freedom. Itong node na to, isa lang. Okay? How about for plate 2? Fix, fix, fix. Right? Okay. Dito, tatlo ang fix. Sa plate 1, dalawa lang ang fix. Sa plate 3, halimbawa, how many ang fix? Tatlo din. No? Tapos, meron kang displacement. Dalawa lang din, pero magkaibang condition to. Okay, so on so forth. Right? Okay, so may dalawa akong SMATH code for this kasi medyo Dahil nag-double integral tayo, remember doon sa ating equation dito, double integral, di ba? Kasi nga, yung dating volume integral, naging double integral na lang kasi constant ang thickness. Alright? Okay. So, ito. Okay, this one. So, 0 to A, 0 to B. Okay. Now, pagdating sa SMATH, ito na siya. Okay, so 205,000, kinonvert ko yung problem into metric. Okay, 205 gigapascal, Poisson ratio is 0.3, thickness is 2.5 kasi that is 0.1 inch, right? Then yung A ko ay 62.5 mm. Kasi, remember, yung problem natin, 10 by 10 inch daw, di ba? 10 inch by 10 inch. Okay. Hinati ko pa sa 4. So, if this is 10, this is 5. Kita mo ba? 5. Okay, that's 5. 5 times 25. 125. Sorry. Sorry. So, 10 by 10 pala to. Okay, so therefore, this is 5 na pala to. This is 5. Ito yung 5. This is 5. So, kung hinati ko to, this becomes 2.5. 2.5. So, yung 2.5 by 2.5 inch na to, pag kinonvert mo into metric, that is 62.5 mm. Okay, kaya yung aking element dito, 62.5 by 62.5 each plate. Okay, na ito yung B matrix natin kanina. Yan. Where's that? From here. That's it. Okay. Right? Yan. In-implement ko lang tong B matrix. Ito. Yan. Nilagay ko lang siya sa SMATH. Okay. Then, what's our K? Our K is... Yan. Diba ang K natin? 0 to A. Our A is 62.5. Okay. Ito yun. Ito yun. Yan. No? Focus dito. Yan. Ito siya. 0 to A, 0 to B. Okay. 0 to A, 0 to B. Phi. Ang phi natin is this. Where is our phi? Anyway, yun nga, constant matrix nga pala ito. So, pwede natin ihuli yun, no? Ang mahalaga yung B, no? Because our B is that, so, kailangan ko na siyang establish dito pala. Okay? So, kinuha ko yung B transpose nito. Ito siya. So, pinangalanan ko na lang na B1. That's why here, okay, ito, B1, which is B transpose, and then this is yung C. Ito yung C natin. Okay, yan, ito. This one yung C, or in our lecture, yan, ito yun. Constant to, no? Which is this one. Okay. And then, B transpose C, B. Okay. B transpose D or C or D, B. Alright? So, dx, dy. Okay. Then, what's our x and y? Yeah, yun nga. From our x and y from 0 to A, which is yung size ng ating plate element. Okay? So, pinangalanan ko na siyang variable REC kasi rectangular. So, pag ginawa niya ni SMATH, medyo matagal yung running time. And then, ito yung P. The implementation niyan is here. P. That's it. That is our P. In-implement ko lang sa SMATH. Okay. So I get that. Turns out, my REC is this. Medyo di ko lang na ano pala. Nalinis. No? That is your REC. Yun na yung double integral. But our K is ito. No? Ito yung REC ko. B transpose dB. Then multiply mo sa phi inverse transpose sa phi inverse. Which is this. Then finally, that's your K. Then kinopy-paste ko to. Yung value na to. So ito yung K for each element. Okay. Take note, hindi tayo nag-Gauss quadrature dito, no? Direct, straight, double integral, right? Kasi nga, parang yung ang sinasabi sa concept, yung plate bending na to is just an extension of the Euler-Bernoulli beam. Right? Okay. Okay, so punta ngayon tayo sa part 2. So, after pasting the K, may apat na tayong K. Kasi nga, 4 plates yun. Yan. Okay. And they are all identical. Now, dito na magkakatalo yan. Meron tayo ngayong force vector, which is yung given sa problem. And then ito yung BU and BB matrix ko. If you follow the tutorial, ever since meron, when using this code, meron akong BU and BB to get the S matrix, right? Kasi, remember, ultimately, ang ano niyan, final niyan is P equals SD, right? So, force vector natin ito. To get the displacement, we need to find the S. Yung S, mag-generate yan from K1, K2, K3, K4. Okay. And then D is equal to S inverse P. Okay. So, to get S, sa code ko ng SMATH, may BU and BB matrix. Alright. Okay. So, BU, BB. Yeah. Okay. So, ito yung lumabas na BU and BB matrix. Explain ko mamaya, no? Okay. So, input mo yan. And then, ito din yung ginagamit kong code ever since, no? To get the S matrix. And then, that's it. That's your S matrix. Na ang size ay 1, 2, 3, 4, 5, 6, 7, 8 by 8. Okay. Because if we further analyze yung degrees of freedom, yung S natin lumalabas ay 8 by 8. 6 degrees of freedom pala to. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Remember, 3 unknown, 3 unknown, 3, 3, 3, 3, 3, 3, 3. Right. So, ang lumalabas na may kailangan natin ito, 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 ito. Kasi free end yung mga yan, eh, no? So, 1, 2, 3, 4, 5, 6, 7, 8. That's it. So, yun pala, no? So, 8 degrees of freedom pala to, no? Kamali lang siguro ako sa ano, no? Sa file naming. Okay. So, I need 3 unknowns here. Lumalabas, I have 2 unknowns here, 2 unknowns, and then 1 unknown. Right? Therefore, 8 unknowns. Okay. Kaya ang S mo ay 8 by 8. And I think ang numbering ko dito, if I'm not mistaken, is 1, 2, 3, 4. That's it. Yan yata yung ano ko. Yes. Yes, I think. Yan yung ano ko. Yan yung convention ko ng plate arrangement. Kasi mapapansin nyo, yung BU and BB matrix ko, yan, nag-start kagad ako sa 1, 3, 4, 5. Siya yung may pinakamaraming unknowns. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, sige. So, ako na-discuss, no? Then, once you have that, BU, BB, you get the S, which is this. We have the force vector. Then, you get the D, the displacement. What's our D? This. Alright? Okay, so ito yung displacement ko. Yan. And yung hinahanap natin displacement is actually this. Maximum vertical displacement. So that is 0.3673 inch. Mm. And makikita nyo, yung lahat ng negative, yan yung mga vertical displacements na ano. 1, 2, 3, 4. So, 1, 2, 3, 4. Okay? So, we have 4 unknown vertical displacement. Ang nakuha ko is 0.43673. Kay STAAD is what? 0.436. May konting discrepancy kasi nga unang-una shear deformable plate ang ginamit niya dito. Okay. Sa ating problem, ang exact is what? Ito. Yan. The finite element solution gives a center displacement deflection of 0.0168 inch. How many yun? 0.0168 times 25.4, that is roughly 0.426. 0.42672 mm. So, magkalapit sila ni STAAD. Right? So, tayo, merong, yung SMATH code ko, may discrepancy, no? Most, baka kasi sa, random error, no? Yan. So, 0.36 lang nakuha ko. Okay? Pero, if you notice, may may trend, no? Siya yung maximum. Right? Understandable. Dapat naman talaga. Siya yung maximum dito. Okay? Kasi, at least siya pa rin yung pinakamalaking deflection compared dun sa other. Yan, okay. So that's it. We were able to compare the manual solution using SMATH code with STAAD. I have another MATLAB solution for this. Okay. For now, ito lang muna. SMATH and STAAD. Okay. So 0.436. Okay, so discuss ko yung BU and BB matrix. Balikan ko yung BU and BB. Baka kasi malito kayo during the implementation pag nagpa-solve na ako ng problem. Okay. For example, kunin ko nga yung BU and BB. That's it. Okay, paste. Ilakihan ko. Yan, okay. 1, 3, 4, 5, 6, 7, 8. So, kasi, save ko muna. Okay. Ito ko siya dito. Medyo, you need to concentrate here. I think, 3 days ko yata ito pinag-isipan. Solve manually. But it's all worth it. No? Having, fulfilling naman once you do a manual solution of a finite element analysis. No? Remember, ang STAAD is how much? 500K or 300K? No? But to come up with a manual solution and compare it with the commercial software is, for me, it's all worth it. Okay. So, ang BU ko is 1, 3, 4, 5, 6, 7, 8, 10 for plate 1. This is plate 2, plate 3, plate 4. Kasi, ang numbering ko nito is 1, 2, 3. I think this is 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me see. Okay, so balik tayo dito. Ito pala yung correct correct numbering. Yan, naalala ko na. Yan. So, extract ko ulit lahat to. Yan, pag ganyan. Okay. So, yun yung advantage pag automated na tong coding mo. No? Sa SMATH ko, hindi pa yun. Kasi at least iba pa rin yung mano-mano mong aalamin yung code. Sa STAAD, automatic na to, definitely. Okay, so 1, 2, 3. Remember, ang unknown displacement ko dito is how many? Lagyan ko ng support. Yan, okay. So, I have 2 unknown displacements here. Ang kinuha ko lang is 1 and 3. Yan, kaya 1 and 3. Okay? Ni-restraint natin siya sa theta 2. Or rather, degrees of freedom 2. Kasi meron kang vertical at tapos may isa kang rotation dyan. Yun yung assumption. While here, full lahat ng degrees of freedom activated dito. 4, 5, 6. Kaya kinuha ko yung buong 4, 5, 6. Dito naman, ganun din. Same story dito. Dalawa lang din dito. Vertical displacement, which is 7. Tapos yung rotation on this side, which is 8. Code 8. And finally, dito, isa lang ang displacement, or rather, ang unknown displacement, which is the vertical, which corresponds to 10. Okay, that's it. Now, punta tayo sa plate number 2. Okay, plate number 2. Pag ganun yung natin, yung naming natin, right? So, this is, sulat ko dito, plate number 2, 1, 2, 3, 4 to 6, 7 to 9, and then 10 to 12. Okay. So, dahil pag ganun yung ikot natin, so ano yung unknown ko dito? Dalawa, which is 10 and 12. Ito yon. Okay? Dito. Ilan yung unknown? Wala. No? Fix yan eh. No? So, wala kang makikita dito. Okay? Dito, ilan ang unknown? Wala rin. Fix yan. Wala din, di ba? Dito, ilan ang unknown? 3. 7 to 9. Kaya ito. Okay? So, punta tayo sa plate number 3. Ilan ang unknown dito? Sorry. Dito pala tayo mag-umpisa. Ilan ang unknown? 3. That's why that is 10, 11, 12. Okay? The rest yan 3. Fix yan. Kaya yun lang ang unknown sa 3. So, ganun din ang istorya sa plate 4. Okay? Dito. Okay? So, that's it. So, ganun din. No? And, sabi natin, ang total unknowns natin sa S is 8. 1, 2, 3, 4, 5, 6, 7, 8. So, we are expecting. Kaya gusto ko yung gantong coding. Dapat as a user, as a student, alam mo yung in-expect mong S-matrix based sa in-specify mong boundary condition. So, I am expecting an 8 by 8 matrix. So, saan mapupunta to? Si 1. Sa 1 din. Si 3 mapupunta sa 2. Basically, nandito lahat sa plate 1 yung yung lahat ng unknown displacement. That's why siya yung may 1 to 8 na numbering. Alright? How about sa plate 2? 1, 2, 3, 4, 5, Y. Kasi ito si plate 2. Kasi dito tayo nagsimula sa 10 to 12 kanina, no? Kay plate 2. Kasi itong si 10 to 12 is napunta sa 1, 2, 3. Diba? Kaya 1, 2, 3 siya. Diba? Kumbaga, yung 1, 2, 3 ni plate 1 is 10 to 12 ni plate 2. Alright? Eh, ang basis natin ng displacement, yung reference natin is si plate 1. Kasi nandun lahat sa kanya yung displacement. Kaya si 10 to 12 naging 1 to 3. And then, next is, while si 7, 8, 9 na nandito, ni 7, 8, 9 ni plate 2 is, ang counterpart niya kay plate 1 is what? 4, 5, 6. Okay? 1, 2, 3, 4, 5. Right. So, 1, 2, 3, 4, 5 siya. Yan. So on, so forth. So, ganun yung idea, no? I hope you get it, no? So, ganun, no? Okay? So, that's it. That's your BU and BB. And that explains our S matrix, which is nandito. Which is here. Yan. And that explains our displacements here. Take note, that's why kailangan natin ng background sa finite element. Ang STAAD hindi nag-output ng S matrix. No? That's why, no? So if you have no way to manually compute that, how will you know kung tama yung S matrix sa STAAD? Right? So that's it, no? This is one of the reason why I encourage ang mga, lalo na ang structural engineers, should learn the basic of finite element. Okay? So, what else? So, ganun, no? Ito naman sa STAAD. Punta tayo kay STAAD. Ganun din, no? Sa geometry, yan, ito. 62.5, consistent with my SMATH code. Okay? And then, nakita nyo naman na yung rendering. Ito yun. Pinakita ko na rin yung restraint sa supports. Ito rin yun. Okay. And then the loading. Ito. Okay. So that's it. And then once you analyze that displacement, got that. Okay. Ito siya. Yan. See? Okay. Okay. What else? So that's it. So we were able to verify the result of STAAD using manual solution from SMATH code. Okay, from a problem in the textbook. Alright, okay, that's it.